There's a spacecraft out there right now moving faster than anything humans have ever built, 430,000 miles an hour, fast enough to fly from New York to Tokyo in under a minute. And it's not just moving fast, it's flying straight into the sun's atmosphere, close enough that its shield glows at nearly 1,700 degrees Fahrenheit, while 18 centimeters behind that shield, sitting in its shadow, the instruments stay at a comfortable room temperature. This is Parker Solar Probe, and what it's doing sounds less like engineering and more like a dare. For 400 years, humans have studied the sun from a distance, through telescopes, through eclipses, through orbiting observatories that watch from millions of miles away. But watching something isn't the same as touching it, and there's a layer of the sun that no instrument could ever properly explain from far away: the corona. The sun's outer atmosphere, the wispy halo you can only normally see during a total eclipse. Here's the strange part. The surface of the sun sits at around 10,000 degrees Fahrenheit, but the corona, hundreds of times farther from the sun's core, somehow reaches temperatures of over 1,000,000 degrees. Hotter the farther you get. Nobody fully understood why. To answer that, scientists didn't just need a better telescope. They needed to send something inside. That's an insane engineering problem. You're not just building a spacecraft that can survive heat. You're building one that can survive heat while flying through plasma at over 100 miles a second, using solar panels that somehow still need to generate power without melting, using a communication system that has to go completely silent and blind for days at a time. The centerpiece of the whole mission is a shield about 8 feet across, made of 2 carbon composite panels wrapped around a lightweight foam core, roughly 4.5 inches thick. Its sun-facing side is coated in a specially engineered white paint, designed to reflect away as much solar energy as physically possible. The whole shield weighs about 160 pounds, a small fraction of the spacecraft's total weight, but without it, nothing else on board would survive more than a few seconds. The shield doesn't cool the spacecraft, it shadows it. Parker's entire body has to stay tucked directly behind that 8-foot shadow at every single moment during closest approach. Even a small drift in orientation could expose sensitive hardware directly to the sun. So the spacecraft flies autonomously through these passes. There's no joystick, no live correction from Earth. Communication with mission control simply isn't possible while it's this close. The spacecraft is entirely on its own, trusting its own programming to keep its most fragile side turned away from a star. Even the solar panels, the very things generating the spacecraft's power, have to partially retract during closest approach, shrinking down to just a narrow sliver still catching sunlight, because fully exposing them would destroy them. Parker launched in August 2018, but it didn't fly straight at the sun. It couldn't. Getting close to the sun is counterintuitively one of the hardest things to do in the entire solar system. Earth's own sideways orbital speed means a spacecraft needs to shed an enormous amount of momentum just to fall inward. So Parker used a series of flybys past Venus, 7 of them spread out over years, each one using the planet's gravity to steal a little more speed and bend its orbit closer and closer and closer to the sun. Each close pass, called a perihelion, pushed the spacecraft further into unknown territory. The first, back in November 2018, brought it in enough to heat its shield to around 820 degrees Fahrenheit. Hot, but nowhere close to the mission's real limits. With every following Venus flyby, the orbit tightened and the numbers climbed. By December 2024, after its final Venus flyby, Parker reached a distance of just 3.8 million miles from the Sun's surface. If you shrank the entire distance between Earth and the Sun down to the length of an American football field, Parker would be standing about 4 yards from the end zone. At that distance, its heat shield reached somewhere around 1,600 to 1,800 degrees Fahrenheit, and the spacecraft hit its peak recorded speed, 430,000 miles per hour, officially recognized as the fastest speed ever reached by a human-made object. And here's the part that should sound impossible. None of the mission team could watch it happen in real time. During the pass itself, Parker is completely out of contact. No telemetry, no confirmation, nothing. All engineers on Earth can do is wait. For this particular encounter, they waited 2 full days after the flyby for a single simple radio beacon, barely more than a tone, just to confirm the spacecraft had survived and was still operating normally. It came through. Parker had done it, flown directly through the Sun's corona, faster and closer than anything built by human hands ever had, and it kept working. It wasn't a one-time stunt either. Parker has now matched that same record distance and speed across multiple passes since, each one gathering more data from directly inside the region scientists spent 4 centuries only able to observe from far away. Among its discoveries, strange zigzag kinks in the Sun's magnetic field, called switchbacks, that may hold the key to understanding why the corona is so much hotter than the surface below it, the very question that sent Parker out here in the first place. The mission isn't finished. Parker is designed to keep tightening its orbit, chasing the Sun even closer in the years ahead, repeating this same terrifying sequence of silence and heat, and hoping the shield holds again and again. What's remarkable isn't just the speed or the heat, or the fact that a spacecraft the size of a small car can survive conditions that would vaporize almost anything else humans have ever built. It's the quieter achievement sitting underneath all of it, a machine flying blind, alone, closer to a star than anything in history, trusting nothing but its own engineering to keep its shadow exactly where it needs to be, one silent pass at a time.